Okay, so last meeting, sinimulan natin yung discussion sa equations of motion at kung paano natin gagamitin yung tawag dito, Newton's laws para mag-solve ng simple na physics problems. Okay, and we also considered familiar na physics problems involving yung motion ng object along the horizontal tsaka along the vertical. Along the horizontal, of course, ang forces lang na kinonsider natin ay yung um, tawag dito ay yung friction, okay, along the horizontal. And then, of course, may andun din yung gravitational force sa vertical, pero if we're only going to consider yung acceleration along the horizontal, then yung friction lang yung nakaka-affect doon. Hindi friction, kundi air resistance, okay? On the other hand, dun sa projectile na pababa, okay, na vertically moving, unang kinonsider natin without resistance, and then sunod, dinagdagan natin ng resistance at tinignan natin kung ano yung equations na nalalabas. Okay? Um, Now, we are going to extend that discussion at titignan natin kung ano ang mangyayari pag two-dimensional na yung problem. So basically, this is just an extension of yung one-dimensional problem. Remember na sa Physics 101, tinuro o ang isa sa mga natutunan ninyo is that yung motion along the horizontal is different or is independent along dun sa motion along the vertical. Okay, so you can treat both motions independently. Okay, and in that way, it will make things easier. Then, once na makuha nyo na yung tawag dito, velocities and um, equations for displacements, then from there, pwede nyo makuha yung range ng projectile. Okay, and in this case, it's the next two problems na i-consider natin. Titignan natin yung range with and without air resistance. So itong first example, okay, na nakikita ninyo dyan is we are going to treat the projectile into dimensions without considering air resistance. Okay, so let the muscle velocity of the projectile be equal to V naught and the angle of elevation be equal to theta. So we want to calculate the projectile's displacement, velocity, at saka range. Okay. So let's see. First of all, anong kailangan nating gawin dito? Ang una natin ginagawa is i-identify natin yung forces acting on the object. And in this case, yung objects na nag-act, yung forces na nag-act sa object na yun ay yung gravitational force. Okay, and well, since it is a projectile, then the only force acting on the object is the gravitational force. And it is acting along the vertical axis. Which means na if we sum yung forces along the horizontal, okay, so if we sum the forces along the horizontal, then we get, well, we don't have any forces, so zero yung force dyan, but this is still equal to mx double dot. Okay, and along the x-axis, this tells us that x double dot is equal to 0, and if we integrate that once with respect to time, we get the velocity, diba? So the velocity with respect to time will just give us some constant. And if we say na at t equals 0, the velocity is equal to the initial velocity, or the velocity is equal to v naught. Okay, sulat natin ng maayos. X dot naught is equal to v naught. Okay, then x dot is equal to v naught at t equals 0, which means na ang x dot, well, sorry, x dot is not v naught but v naught cosine theta. Okay, since merong angle, di ba? So x dot is equal to v naught cosine theta. Okay, and from there, integrate ulit natin one more time to get x. So when we integrate that, it's just simple integration with respect to time. Okay, so we get this equation. Okay, so this is quite straightforward. Of course, pwede nyo lagyan ng c dyan kung gusto niyo, and then apply the initial conditions. So t equals 0, x is equal to x naught if you like, or x is equal to 0. Then if x is equal to 0, then c is equal to 0. Okay, so we don't have to worry about the constant. Okay, so ito yung equations of motion along the x axis. Now, along the y-axis, we have itong gravity. And if we consider the positive direction to be upward, so along the y-axis, we have negative mg is equal to my double dot. Okay, so we can cancel out the mass. So y is equal to y double dot is equal to negative g. And so y dot is equal to negative gt plus some constant, and then apply the boundary condition na at t equals 0, yung initial velocity or yung y dot is equal to the initial velocity along the y-axis. Okay, and so this will give us y dot is equal to v naught sine theta minus gt. Okay, already familiar na sa inyo itong equation na ito. This is the kinematic equation. Then if we integrate once more, we get y is equal to v naught sine theta t minus 1/2 gt squared plus some constant. And then if we apply the initial condition, t equals 0, y is equal to, let's say, 0, then this constant is just equal to 0. So y is equal to v naught sine theta t minus 1/2 gt squared. Okay, so that's quite straightforward. Okay, we derived from this starting equation and by using Newton's laws, we simply derived yung kinematic equations na ginagamit natin na ginamit ninyo sa 101. Okay, now in the next problem, okay, we're going to take a look at the effects of air resistance. Okay, so mamaya na balikan natin yung figure niya. So, what about if there is air resistance? Ano nang mangyayari dun sa projectile? Oh, sorry. Kailangan pa pala natin i-compute yung range, no? Kasi na-compute natin yung displacement, yung velocity, at saka ngayon, ang kukompute natin ay yung range. So, what I'm going to do is just, okay, so, tanggalin ko lang tong figure na to. Delete. So, now I have a blank page, and we can compute for the range. Okay. Well, technically, ang pinapahanap dito is displacement, velocity, and range. So if you really want to solve for the displacement, so we have the total displacement, okay, r. This will simply be equal to just x squared plus y squared, okay, since these are vectors, diba? And since x is, ano yung x? V naught cosine v naught squared cosine squared theta t squared, and then yung y is v naught squared sine squared theta t squared minus 1/2 1/4. Okay. Okay, minus 1/4 g squared t to the fourth. Okay, and then we take the square root of that. Okay, yan na yung, well, we can simplify it further. V naught squared t squared minus 1/4 g squared t to the fourth. Okay, so yan yung ating range. Okay, pwede nyo pang i-factor out yung t kung gusto niyo. So v naught squared minus 1/4 g squared t squared. So then may t dun sa labas. Okay. So this is the displacement, sorry, not the range. And if you want to solve for the velocity, then we get v is equal to x dot squared plus y dot squared square root. Ang x dot is just v naught cosine theta. Okay, and if you square that, you have this result, and then ang y squared is v naught, y dot squared is v naught squared sine squared theta minus g squared t squared. Take the square root of that. So this will be equal to v naught squared minus g squared t squared. Then yung square root niya. Okay, so yan yung velocity. Now for the range, anong ginagawa niyo sa 101 nun para ma-solve yung range? Ang ginagawa niyo sa 101 ay tinitignan niyo yung y displacement. Okay. So if we go back to the figure, ito yung tinitignan niyo. Okay. So if this is yung starting position niya, just change yung color konti. Okay, kung ito yung kanyang starting position, okay. So dyan yung starting position, yung final na position, and if you want to compute for the range, okay, we say na yung final position niya is at the same level as at the starting position. So if its starting position is at y equals 0, di ba? Ito yung initial condition natin. Then yung final position niya to solve for the range is at y is equal to 0. Okay, so yung final position is at y is equal to 0. Okay. And since we already have this equation, okay, for the tawag dito, for the vertical displacement, so y is equal to v naught sine theta t minus 1/2 gt squared. So if we set that to 0, this will give us v naught sine theta minus 1/2 gt t is equal to 0, and meron dalawang solutions dyan na t equals 0 at saka t is equal to 2 v naught sine theta over g. Okay. Ang interpretation natin kung bakit dalawa yung solution is that at this point, okay, itong point na to, yan yung y equals 0 at t equals 0, and then itong point na to, yan yung y equals 0 at t is equal to 2 v naught sine theta over g. Okay, now that we know yung time at this position, we can now plug this time in the equation for this horizontal displacement, which is this one. So pag pinasok natin yan dun sa equation yan, x is equal to v naught cosine theta t is equal to v naught cosine theta times 2 v naught sine theta over g. Okay, itong 2 cosine theta sine theta is just sine 2 theta. So this gives us v naught squared over g sine 2 theta. So yan yung ating range ngayon. V naught squared over g sine 2 theta. Okay, so now we have solved for the velocity, the displacement, and the range, okay, as required dun sa problem. Okay. Okay. So next, we consider yung effects ng air resistance. So ano ngayon ang mga forces acting on tawag dito, the object. Okay, hindi na natin siya tinatawag na projectile dahil by definition ng projectile is an object that experiences only one force, and that force is gravitational force. Okay, so it's no longer a projectile. Okay, so it's an object undergoing experiencing air resistance. And in that case, kung ito yung object, ano yung mga forces na nag-act sa kanya? So, ang forces na nag-act sa kanya, of course, ay yung weight, okay, ng object, which is always vertical. Okay, and okay, kung ah, kung kung meron tong air resistance, let's see na ito yung consider natin na air resistance. Remember that the air resistance, so yan, ganyan. Remember that the air resistance is always opposite to the direction of the motion. Okay, so, and yung air resistance na to, okay, will have a component along the x-axis at saka along the y-axis. Okay, so this will make things easier for us kasi when we sum the forces along the x-axis, we'll have a component of this air resistance along the x-axis. Okay. And in the previous example, actually, ginawa na natin ito, kmx double dot. Okay, remember that um, ang tawag dito, that the air resistance is proportional to the first, kung very small velocities lang siya, proportional to the first power of the velocity. Okay, and it's also proportional to this constant, yung air resistance na constant. Constant. Okay, so ganyan yung expression natin for air resistance. Okay, and along the y-axis, we have negative kmy double dot minus mg. Okay, sorry, kulang to. Wait. Dali check lang natin. MA is equal to negative KMV. KMV. So this should be a single dot. Okay, and ito ay single dot lang. KMY minus MG. Okay, so this will be equal to MX double dot and this will be equal to MY double dot. Okay, so sinolve na natin to last time. Ito yung exercises na ginawa natin last time. Ang difference lang is that dun sa examples na yon, yung V naught ay walang component. Okay, this time yung V naught ay merong initial velocity, may component along the x tsaka along the y-axis. So dagdagan lang natin siya ng sine theta at saka cosine theta. Okay, and since we already solved this last time, we know kung ano yung displacement. Ang displacement is along the x-axis ay x equals u k 1 minus exponential minus k t. Okay, sorry, k t. Okay, and then yung displacement para sa y is negative gt over k plus kv plus g over k squared 1 minus exponential minus k kt. Okay, so by the way, yung u at saka yung v, yung u is v naught cosine theta at yung v ay yung v naught sine theta. So these are the initial velocities. So at t equals 0, u is equal to u naught is equal to, or u is equal to v naught cosine theta and v is equal to v naught sine theta. So para alam niyo kung ano tong u na ito at saka yung v na yan. Okay? So, ano ngayon ang mangyayari dito? So, of course, in-expect natin na yung range magdi-decrease, 'di ba? Dahil may air resistance, and yun nga yung pinapa-compute. Calculate the decrease in range under the assumption that the force caused by air resistance is directly proportional to the projectile's velocity. Okay, so yun yung ginawa natin dito. Okay. So how do we solve for the range? Well, ang ginawa natin before is, kung walang air resistance, is para ma-solve yung range, sinet muna natin yung y to 0. And then saka natin kinuha yung, kinuha natin yung time. Okay, tapos, yung time na masosolve natin, yun yung ipa-plug in natin dun sa x to get for the range. Okay. So if we do that, ito yung expression natin for y. And if we set that to 0, what will we get? Okay. So let's see, negative, so we set y to 0. So we get negative gt over k. Okay, ilipat ko na sa kabila, no, yung gt over k. Ayan, para positive na siya. Equal to kv plus g over k squared, 1 minus exponential minus k t. Papalitan ko itong small t ng capital T to indicate na ano, hinahanap natin yung t. So yung t is equal to t at y is equal to 0. Okay, and then ano mangyayari dito? So t is equal to, so I just multiply all of these by k over g para ma-isolate yung t sa left-hand side. So we have k v plus g over g k. 1 minus exponential minus k. Okay, now take a look at that expression. Yung expression na yan is a bit problematic because paano nyo isa-solve yung ano, yung time? Okay. Kasi may time ka sa left-hand side and may time ka na at nasa exponential pa yung time na yon sa right-hand side. So this is called a transcendental equation. Okay, kasi kailangan mong isolve simultaneously both left and right-hand sides, right? Okay, para makuha yung time. And it makes it even more complicated kasi yung left-hand side is, sorry, yung right-hand side is may exponential. Okay, yung time is dependent on the exponential. Okay, so yun ang ano dito. Yun ang mahirap isolve dito. But still, this is solvable. We can make some assumptions, okay, and try to see if we can get an expression for t, and then once we get an expression for t, then we plug that in to x. Okay, yun yung isang method. Okay, so we make a lot of certain assumptions. Second thing we can do, of course, is numerical method. So, gagamitin yung skills nyo sa computational physics. So let's do the approximations first. If you read the book, ang tawag niya dito sa approximation ito is a perturbation method. Okay, basically, ang gagawin natin is i-expand lang natin itong exponential. Okay. And then kukunin lang natin yung certain terms, and because we're only getting certain terms, then may ina-assume na tayo about certain parameters. Okay, tapos then we can solve for the period, or not for the period, for the time. Okay, so let's first expand yung tawag dito yung exponential. So when we expand the exponential, we have 1 minus 1 minus kt plus 1/2 k squared t squared minus 1/3 or 1/6 kasi 3 factorial k cube t cube plus 3t cube plus and so on and so forth. Okay. Itong 1 na ito, tsaka yung 1 na nagaling dun sa exponential will cancel each other out. Okay. Yan, magka-cancel. At ang matitira ay yung kt. So, t is equal to kv plus gk kt minus 1/2 k squared t squared plus 1/6 k cube t cube minus and so on and so forth. Okay. First na ano natin, first na assumption. We assume that k is small, which means na hindi na natin isasama yung well, not that small siguro. Hindi natin isasama yung mga terms from the third term. Okay, so itong mga to, okay, not included or it can be tawag dito ignored, okay, because we assume na k is less than 1. It's still tricky to get an expression for t because of this expression here. Okay, so ang gawin natin ay ang gawin natin ay, well, i-multiply natin yan. So, t is equal to, let's see. Okay, sandali t is equal to kv plus g over g, cancel yung k doon, and then times t. Okay, minus kv plus g over g, tapos may k ka sa ibabaw, and then may 2 ka dyan, then k sa ibabaw, and then t squared. So, kv, let's see, kv over g p plus t minus 1/2 kv over g minus 1 over 2g k t squared. K squared t squared, and then kg k t t squared. Okay, kvg. Okay, so okay. So, sorry, ulitin natin. Ilipat ko sa kabilang side itong i-encircle sa blue. So what I have is gkt over kv plus g is equal to kt minus 1/2 k squared t squared. Okay. Then nililipat, i-arrange ko to. G, KT. Ganito ang gawin. G over KV plus G minus 1 KT. So nilipat ko yung KT sa kabila is equal to 1/2 K squared. T squared. So what I have is G minus KV minus G over KV plus G times KT is equal to 1/2 K squared, T squared. So magka-cancel yung G, of course. So we have negative KV. Okay. Ni-retain niya yata itong hanggang 2 terms. Okay, so 1/2, let's see. Okay, so I seem to have, I seem to need more time para ma-derive yung equation na 2.47. What we're supposed to end up is 2V over G, 1 plus KV over G plus 1/3 KT squared. And ayoko mag-spend ng time, ng buo nating time dito. So what I'm going to do is just derive this later and then show you send you the derivation. Okay, so dito tayo dapat mag-end na equation na ito. So once we have that, we can now expand this. Okay. And ang expansion na gagamitin natin, o ang expand natin specifically ay 1 plus KV over G. Okay, so yung denominator, okay, so ito yung in-expand natin. Equal yan sa 1 minus KV over G plus KV over G squared. Okay, and so on and so forth. Okay, and if we plug this expansion in doon, okay, we'll get T is equal to 2V over G plus T squared over 3 minus 2V squared G squared K, and then you have higher order terms than K squared. Okay, so now we end up with this rather simple equation for T, easily solvable kasi this is just T squared T squared lang. At kayang-kaya nang isolve yung ano na yan, yung expression na yan. Okay, notice na if K is 0, so I'm just going to rewrite yung expression na yan dito sa kabilang, sa next na slide. 2V over G plus T squared over 3 minus 2V squared over G squared times K. Note na if K is equal to 0, then we have 2VG. And remember that V is equal to V naught sine theta. So T is equal to 2V naught sine theta over G, which is nothing but yung expression na na-derive natin without air resistance. Okay. So here. Okay. So which means now we're on the right track. Okay, sa pag-derive ng expression for T. Okay. Furthermore, by using this approximation, okay, anong tawag natin sa approximation na ito? Or sa expansion na ito? Ang tawag natin dyan ay binomial expansion, and may assumption tayong ginagamit dyan, di ba? Pag binomial expansion, sorry. Ang assumption na ginagamit natin dyan is KV over G must be less than 1. So yung term na to must be less than 1. Okay, so immediately meron na tayong dalawang conditions for K. Okay, yan at saka ito. Okay. And mukha namang consistent sila sa isa't isa. But this is a more, this is a stricter assumption kasi it involves yung velocity at saka yung acceleration due to gravity. Okay, so now we have this expression for t. Okay, so what we're saying is na if k is small, okay, then we can write t is equal to 2vg, or approximately 2v over g 1 minus kv over 3g. Okay. Again, ipapakita ko yung steps kung paano na-derive yan in a separate file. Okay, para hindi na tayo mag-spend ng time dyan. Okay, so once we have that expression, we can now go to our expression for x, okay, to solve for the range. And the expression natin for x is this. Okay, and for that to be useful, i-expand din natin yung exponential. Okay, so ang expression natin for x is u, k, and then i-expand na natin to an exponential, t minus 1/2 k squared, t squared minus 1 plus 1/6 k cubed, t cubed, okay, minus. Okay. So, then ipasok natin yung t dyan. What we'll end up with is r prime is equal to u t minus 1/2 k t squared. Okay, and remember that u dito is equal to v naught cosine theta. Okay, no, hindi pa ito na-replace. So we just tawag dito, consider itong first two terms dito. So itong first two terms yan yon. And then we need to replace t dito. Okay, so r prime ngayon is equal to 2uv over g 1 minus 4 k v 3g. Okay. Okay, ang 2uv over g is just 2 v naught squared sine theta cosine theta over g. So this is nothing but v naught squared over g sine 2 theta. Okay. So yung r prime natin is just v naught squared over g sine 2 theta 1 minus 4 kv over 3g. Okay. Immediately, makikita natin na if k is equal to 0, then r prime just reduces to yung familiar equation of v naught squared over g times sine 2 theta. Okay, but if k is not equal to 0, then we have this expression for r. And makikita natin na yung r is linear in k. So, if we plot yung range for different values of k, makikita natin na linear yung shape niya. Okay, remember din na ang condition natin dito is kvg is less than 1 or k is less than g over v. And if you want it to be really small, pwede nyo sabihin na k is very much less than g over v. So we have to select v, specifically v naught at saka theta in such a way na this condition is satisfied. Okay. Now, sa examples na nandito, ang V naught na pinili is about 600 meters per second. And yung theta na pinili is 60 degrees. I think yung theta doesn't matter too much. Yung V naught talaga yung nagmamatter. So, makikita natin dito is that V naught has to be really large, okay, in order for this condition to be satisfied. So, ibig sabihin, yung mga talagang nakaka-experience ng air resistance dito ay yung mga objects na matataas yung velocity. Like bullets, di ba? Yung mga, tawag dito, yung mga canyons, di ba? So, yun yung mga nakaka-experience, yun yung matataas ang velocity, so sila yung makaka-experience ng air resistance. Okay. So yung mass nila hindi gaano nagmamatter. Ang nagmamatter is yung velocity. Okay. Now, what about yung numerical na solution? Okay. So, let me just rewrite dito yung transcendental equation natin. So, just so you understand how it's going to happen. So, kv plus g over gk1 minus exponential minus kp, yung ating transcendental equation. To solve this numerically, okay, what you can do is to solve for the roots. So, ilipat niyo yung t sa isang side para meron kayo expression na isang function na equal to 0. And then solve for t. Okay, you can do that. You can do that sa MATLAB. Okay, what you can also do is graph yung left hand equation, which is just t, di ba? So linear lang siya. And then i-graph nyo yung right hand side na equation, which is 1 minus exponential t. So ibig ko sabihin is this. So if we graph yung t, so linear lang siya. And then yung 1 minus negative exponential has this shape. Yung 1 minus negative exponential has this shape. Okay. Ay, linear. Okay, so, ibig sabihin meron silang isang point kung saan nag-intersect yung left-hand side at saka yung right-hand side. Okay, at yung point na yan, okay, so ito ang axis na to is the t-axis and then yung axis na to is the 1 minus exponential kt. So, yung point of intersection na yan yung point na kung saan, well, yan yung hinahanap natin na value ng time. Okay, so to get a graph, okay, okay, sige. Balikan natin yan. Explain muna natin itong graph na ito. So, anong nakikita nyo dito sa graph na ito? Ang nakikita nyo dito sa graph na ito is yung trajectory, okay, ng objects. Okay, pag 0 yung um, air resistance, okay, at pag nag-increase na yung air resistance. Okay. So habang nag-increase yung air resistance, makikita nyo na yung range, okay, ay paliit din ng paliit. Okay, which is which is intuitive, diba? Yun naman talaga ang ine-expect natin. Makikita nyo rin na yung vertical height, maximum height na maaabot ng bawat particle, okay, also decreases with respect to tawag dito, the value of K. At ano pang mapapansin nyo? Dito, it's parabolic. Now, dito, it looks parabolic pero medyo skewed siya, di ba? Skewed to the right. So, nakikita natin yung effect nung ano dito, nung air resistance. Okay? So, ang effect ng air resistance is binababaan niya yung vertical height and then dinidecrease niya rin yung range, but at the same time, binabago niya rin yung trajectory nung particle. Okay, so to solve for we can also well, we can figure out yung possible values ng ranges. Just like this, di ba? Iba-iba yung range. Depende sa iba-ibang values ng K. Okay, so if we plot that, so ang gagawin natin is we set a certain value of K, okay? Tapos get T and then plug it dun sa expression for X. Okay? Para makuha yung isang value ng range. Palitan mo ulit yung K, okay? Gawin mong 0.01, solve for T, and then plug it here. And then palitan mo ulit yung K, solve for T, and then plug it here. So makakuha ka kaya ng maraming values ng R. And if you do that, okay, ganito yung lalabas. Okay, so for different values of the force constant, okay, of air resistance, nag-iiba rin yung value ng range. And makikita nyo na yung range ay lumiliit. But if we use yung approximation na ginamit natin kanina, ito, use this approximation, we'll see na linear lang yung range. And yun nga yung in-explain natin kanina. Linear lang tong range na to. Okay, at ang slope nito is kV over G. Okay. 4 kV over 3G, sorry. 4 kV over 3G. 4 kV over 3G. Yun yung slope niya. Okay, of course, it's negative slope. On the other hand, if we do a numerical solution, it has this behavior. Okay? Yung range has this behavior with respect to the retarding force constant. So, of course, magkaiba sila ng result because yung linear na solution only works dito sa ano na to, sa region na yan, kung saan pareho yung numerical at saka yung approximation. Kasi inassume nga natin na yung K is very much less than 1. Okay, so that's how you solve for the range from the transcendental equation na derive kanina.